Okay, pre-cal, in this video we are going to look at parametric equation application again. And so we have James throwing a baseball with an initial speed of 145 feet per second at an angle of 20 degrees to the horizontal. The ball leaves his hand at a height of 5 feet. So now our initial height is not 0, it's 5 feet off the ground. So when we find our parametric equations, I'm going to have x equals my initial speed of 145 times the cosine of the angle, which is 20 degrees, t, and y is going to equal negative 1/2 times 32 times t squared plus my initial speed times the sine of 20 degrees, t, plus 5, because it's 5 feet off the ground to begin with. So my other equation, I'm going to tidy this up right here. It's negative 16. Okay, perfect. All right, so now we're going to answer the same questions we did in the other problem. So how long was the golf ball in the air? So, oh, that should be baseball. Sorry. Little typo. All right, so how long was the baseball in the air? So it's taking off from his hand 5 feet off the ground right here. And then, of course, it is going to end right here. So I want to know how long it was in the air. So I'm looking for t when y equals 0. All right, now to make this a little bit easier on us mathematically, I'm going to go ahead and find 145 times the sine of 20, so I'm not dealing with so many numbers. So I am going to go to my calculator and type in 145 sine of 20 degrees, and that gives me 49.59. So I'm just going to use that value just to make life a little bit easier. So I've got y equals negative 16t squared plus 49.59t plus 5. Now, unfortunately, we cannot factor out t for this particular problem like we did on the last one because of the 5. So that means we're going to have to solve for this equation when y equals 0. And the only option we have, since we're not using our calculators, is going to be using the quadratic formula. You're welcome. Remember that this is A, this is B, this is C. X equals negative B, so negative 49.59, plus and minus the square root of B squared minus 4AC all over 2A. You're welcome. Okay, now I want you to notice what's happening here. All right, this is negative. We're going to be dividing by negative 32. So in order to ensure that we get a positive value for x, which has to be positive because we don't measure time in negatives. Oh, I'm sorry, I said x, that should be a 0. I don't know what's wrong with me. See, but we're finding t, right? How long? So t is only measured in positive values. So we have to make sure that this right here, we don't need both of these values for our quadratic. We don't need both of these. We only need the negative because we want to make sure we have a negative in the numerator because we for sure have a negative in the denominator. So I'm going to go to Desmos now and I'm going to type this in. So I'm going to have negative 49.59 minus the square root of 49.59 squared. And then that is going to be minus 4 times A times C. So that's negative 4 times negative 16 times 5. So minus, open parentheses, 4 times negative 16 times 5. And then I'm going to take that value and divide it by negative 32. So I get 3.2 seconds. So that is how long the ball's in the air. Okay? All right. Now the next question, when was the ball at its maximum height? So I'm going to use this formula right here to find that. So negative b, well remember b is right here. So 49.59 divided by 2 times a. A is negative 16. So I've got negative 49.59 divided by negative 32. That gives me approximately 1.55 seconds. And determine the maximum height. So I want to know, remember this is the height, so I want to know the y value at this point. So I'm just going to use my y equation, negative 16 times 1.55 squared plus 49.59 times 1.55 plus 5. And then just you can approximate that in your calculator. It's 43.43 feet. Okay, so now part D, determine the distance the ball has traveled. So now I want to know the distance, so I want the x value. So I'm going to use my x formula right here. So x equals 145 times, times the cosine of 20 degrees. And I know that the ball was in the air approximately 3.2 seconds. So you can plug that into your calculator. You get approximately 436.02 feet. Groovy, and we're not going to do this last part.